Thank you for this opportunity to join today's panel discussion and to highlight our recently published review article focusing on trends impacting horseshoe crab sustainability, which I am pleased to note was inspired by two National Science Foundation-sponsored interns, Waleed Ali and Jordan Crisfalusi Gannon, working at Kepley BioSystems last summer, and who became the paper's lead authors and believed it was important to renew awareness of the horseshoe crabs and recent trends. As most of our references reminded us, horseshoe crabs are indeed among the most ancient living species and have long fascinated the public and researchers with their kinship to spiders rather than their namesake. In addition to the keystone role of their eggs as a vital food source for migratory shorebirds, several of our sources noted how they have become the preferred bait for commercial eel and whelk fisheries along the Atlantic coast. Their unique, copper-rich blue blood has also been harvested as a precious resource in the biomedical industry to ensure the sterility of injectable drugs and implantable devices for millions of patients every year. As those of you in attendance are well aware, we highlighted how the horseshoe crab has survived through the ages with an innate immunity based on granular amoebocytes, which are instantaneously sensitive to gram-negative bacteria at parts per trillion. Of course, this unparalleled characteristic underpins their use in the primary, FDA-approved method for endotoxin testing, also known as the Limulus amoebocyte lysate, or LAL test. Specifically, we also hoped our review would help illuminate how these granular amoebocytes come into contact with an endotoxin, or lipopolysaccharide. A cascade of defense molecules is released, triggering coagulation and neutralization of the pathogens. And today, the World Health Organization recognizes methods using amoebocyte-derived LAL that include measuring gel clot formation, turbidity, and chromophore release endpoints. While biomedical industry testing has depended on harvesting their amoebocytes and returning them to water, we particularly noted how horseshoe crabs, especially egg-bearing females, became popular for consumption as bait in commercial eel and whelk pots in the 1990s. In Delaware, knobbed and channel whelks were cited as the third most valuable fish stock after blue crabs and striped bass, while the commercial value of whelk fishing in Virginia, Rhode Island, and New Jersey has been estimated as an $8.5 million sector. Horseshoe crabs have also provided bait for combined recreational and commercial eel fishing along the eastern seaboard, which had been reported as reaching approximately 13.6 million in 2015. Industrialization, tourism, and population growth have also contributed to declining coastlines, ocean changes, and extreme weather events. These factors are projected to have significant impact on horseshoe crab spawning and viability, and were cited by several of our review sources. In addition to these citations in our article, I would also like to add that researchers at the U.S. Geological Survey predicted as early as 2014 that a majority of the Atlantic coastal area could be altered dramatically in the next 35 years, receding by at least 1 meter per year. We also highlighted how horseshoe crabs play keystone roles as bioturbators, hosts to a variety of epenmois on their shell, controllers of the population of many benthic invertebrates, and as a food source for a multitude of marine animals. Shorebirds, sand shrimp, and fish consume their eggs and larvae. In turn, crabs and pufferfish eat juveniles. In our review, yet other authors focused on the impacts observed as horseshoe crabs spawn in the Delaware Bay between May and June, with 70% occurring during the first two tides in May, and how migration of shorebirds corresponds to these patterns, enabling many species to complete the final leg of their journeys to northern breeding grounds. Red knots, semi-palmated sandpipers, ruddy turnstones, and sanderlings are notably dependent on such flyover stops. Ensuring a consistent and sustainable supply of horseshoe crab eggs was of particular concern with respect to the work of those studying the red knot, which has been listed as a threatened species, and may be one of the most studied proxies for tracking horseshoe crab population viability. As many of you are aware, the population of red knots in Tierra del Fuego, Argentina, had reportedly declined from 51,000 in the year 2000 to 27,000 in 2002. Further, in January 2003, an aerial survey of red knot sites along the Patagonian coast, known to be abundant in the 1980s, located only 560 red knots. Likewise, a survey of northern Brazil in December of 2003 indicated an abnormally small population of birds, suggesting evidence of red knot mortality rather than just redistribution. Consequently, in addition to uncertainties regarding horseshoe crab populations as reflected in these shorebird observations, many authors cited other factors that have raised concerns regarding their long-term viability. With a peak of nearly 6 million pounds reportedly used as bait in 1997, the decline of horseshoe crabs in the Mid-Atlantic region has prompted several states to impose significant restrictions. As many of you also might recall, these were supported by the adoption of the ASMFC Horseshoe Crab Fishery Management Plan in 1998, which provided initial management in and around Delaware Bay. Notably, the capture of horseshoe crabs for bait in any fishery in South Carolina is prohibited. From 2004 to 2012, the number of crabs delivered to biomedical bleeding facilities reportedly increased from just over 340,000 to some 612,000, or by about 78%. The ASMFC maximum 15% mortality limit reflected about 58,000 at that time. In 2006, we also noted that the ASMFC estimated the biomedical industry loss as a range of 23,000 to 140,000, with a projection of 70,000 deceased crabs following amoeba site harvesting. In fact, a range of programs have been well documented for stock management, state quota regulations, and best practices for biomedical harvesting. Industry stakeholders have also successfully lobbied for moratoriums on capture of horseshoe crabs as bait, giving their critical value to human health, and the dramatic growth in medicine and unabated demand for safe drugs and devices. Given such growth in the biomedical industry and the uncertain viability of horseshoe crab populations cited across many of our sources, alternative endotoxin tests have been developed and may eventually replace or supplement the LAL methods to ease the demand for wild amebicide harvesting. These might yet include the recombinant factor C or monocyte activation test. However, any new methods would require exhaustive validation, as often noted in this context, to maintain FDA standards while delivering practical applications for routine use in sterility testing. To date, widespread adoption of any alternative methods has not yet taken place at the time of our article's submission. In fact, a few authors suggest that revising current systems may be more viable in the near term, rather than changing tests. Some biomedical companies have opted to make existing tests more efficient. For example, we noted reliable LAL assays have been developed with specially designed cartridges using 1/20th of the horseshoe crab raw material as required by conventional methods. Given many of the insights gained in the course of this literature review and the near-term reality of medical safety and global industry growth, our team has proposed innovative approaches to enhance horseshoe crab viability and ultimately eliminate wild capture as a long-term conservation strategy. We particularly noted how horseshoe crabs have often been studied in captivity, primarily using standard tanks and biological filtration, with typically discouraging results. Their vitality appeared in compelling accounts to rely on tidal, lunar, and solar exposure to maintain circatidal rhythms. They are also have been shown to require adequate foraging space to locate and digest their food, which is uniquely dependent on their mobility while eating. In turn, our team is planning to study what we have coined free-range aquaculture, whereby managed bleeding protocols with minimal habitat extraction could provide biomedical harvesting while eliminating off-sited, distant transportation to and from bleeding facilities and working to optimize well-being in a natural setting. We have also proposed a harvest approach using an implantable catheter, which could improve LAL yield and minimize overall impact from such harvesting. In conjunction with an enclosed habitat, a finite number of horseshoe crabs would be fed, monitored, and carefully bled following optimal protocols for in situ bleeding that would also reinfuse the plasma to avert hypervolumemia. And as Kepley BioSystems has been seeking disruptive innovations to avert the collapse of forage fish used as crustacean bait, we are now hoping to obtain funding to apply that know-how to likewise providing a totally sustainable alternative to the use of horseshoe crabs as whelk and eel bait, which we noted with alarm accounted for at least half of the annual capture and of course nearly all of the human causes of mortality for the species. Specifically, with R&D funding from the National Science Foundation and research published in the Journal of Global Ecology and Conservation, Kepley BioSystems is likewise seeking partnerships to scale up and commercialize organobait, a synthetic and sustainable application of naturally occurring molecules for the crustacean fishing industry, now consuming an estimated 18 million metric tons of bait fish annually. We believe we can optimize this product for whelk and eel fishing with another research grant in the near term, and thereby take another major step forward in horseshoe crab conservation. And given the various published projections for continued environmental and climate challenges to horseshoe crabs, near-term supplements for shorebirds are also on our radar. Kepley BioSystems has established feasibility for developing an easily digestible feed to alleviate diminishing access to adequate nourishment due to climate change, horseshoe crab capture and harvesting, habitat destruction, and pollution, with a goal of aiding in shorebird conservation, as well as that of horseshoe crabs. So thank you for this opportunity to recap our review article in hopes of enhancing awareness of these recent dynamics affecting horseshoe crabs in both the academic and public sphere. As I appreciate our schedule, I will close now and invite you to learn more about our goals and vision for global solutions at KepleyBioSystems.com. Thank you.